Hello everyone. Now we have to discuss the concept of ideal transformer using coupled circuits. This is very important concept. Before that, first we have to write for ideal transformer K should be equals to 1 and there are no resistive branch. R1 should be R2 should be equals to 0 and this is first observation. Second one, ideal transformer is lossless, that is primary coil power, that is equals to secondary coil power, right? You can write primary coil power is equals to coil power, right? So we all know that through primary, what is the input supply voltage and current? V1 I1, which is equals to V2 I2. This is about ideal transformer characteristics. We will discuss in detail while discuss the concept of electrical machines, but this analysis due to what? Mutually coupled circuits. Okay, with respect to we are providing the concept of ideal transformer with what? Mutually coupled circuits. First, consider ideal transformer coupled circuit. So for ideal transformer coupled circuit, like this, okay. So having V1 AC supply voltage through this, what we are having, we have I1, like that. This is I2, or you can say this is minus I2, right? You all know that if this is I2, this is minus I2. Let us say we have a load, but across load we have a voltage, right? Then let us say this is dot convention. Okay, now we have what? Positive value of M, and provided K is equals to 1, right? K which is equals to 1. This is ideal transformer and this is L1, L2. There. What about M? M which is equals to we have positive value of M, right? Plus M. That's it. Here very important observation, turns ratio. Consider turns ratio is equals to N is to 1. This is very based upon the turns ratio only we can do the analysis. That is, turns ratio means what? Primary turns by secondary turns should be equals to N by 1. Okay, that is. right? That is turns ratio means what? Here this is n is to 1. Okay, on primary side we have n number of turns, but on secondary side we have only one turn. That is the meaning. Okay, let us assume this is one turn. So turns ratio in this case is n is to 1. So primary turns to secondary turns is nothing but n by 1. So now we can start the analysis. Apply KVL in primary and secondary. Apply KVL in primary and secondary loops, right? Therefore V1 is equals to, we all know that L1 into di1 by dt plus this is what m di2 by dt. Clear? Like that V2 which is equals to what? L2 di2 by dt plus m di1 by dt. Clear? Now we can write this V1. Let us say this is J omega L1 into I1 J omega m into I2. Like that V2 which is equals to what? J omega L2 I2 J omega m I1, right? So we all know that this is the representation for what? Time domain, right? So this is for what? Frequency domain. Clear? So we all know that current enters through dot ends. Therefore given m positive, right? That's it. So from this, let us V1 by V2 which is equals to what? V1 by V2 is nothing but what? So J omega gets common, right? Therefore finally we have what? L1 I1 plus m I2 by L2 I2 plus m I1. Okay, that's it. What about K? K is 1 for ideal transformer. We don't have the value of m, right? But we know that for an ideal transformer K which is equals to 1, therefore m which is equals to square root of L1 L2 only, L1 L2. Therefore substitute m into this equation. Substitute this m into this equation. Therefore V1 by V2 which is equals to L1 I1 plus square root of L1 L2 into I2 by L2 I2 square root of L1 L2 into I1. So finally what we have? V1 by V2 which is equals to square root of L1 by L2 into this is what? Square root of L1 I1 plus L2 I2 by L1 I1 square root of L2 I2. So from this part gets cancelled. So finally what we have? V1 by V2 which is equals to square root of L1 by L2. So from this analysis we have this, right? Let us say this is 1. Let's say this is 1. Next, in a linear circuit, You all know that L1 by L2 which is equals to N1 by N2 whole square, right? And N1 by N2 which is equals to L1 by L2. Right? This is equation 2. So from 1 and 2, from 1 and 2, we can have V1 by V2 which is equals to N1 by N2, right? Which is equals to turns ratio which is equals to N by 1, that is N is to 1. This is very, very important relation. That's it. We know that primary power should be equals to secondary power, right? Secondary coil power, which is equals to what? V1 I1 which is equals to V2 I2, or we can say V1 I1 which is equals to V2 minus I2. Why minus I2? This is correct. This is for plus M or minus M, right? Because in two-port network analysis we can do the analysis in this method or in this method. We can do the current direction either clockwise or anti-clockwise. Therefore we can have V1 by, from, let us consider this equation. From this you can write minus I2 by I1 which is equals to what? V1 by V2 which is equals to what? N by 1. Therefore finally, thus in ideal transformer V1 by V2 which is equals to N1 by N2 which is equals to minus I2 by I1, or we can say I2 by I1, okay, no problem at all, which is equals to N by 1 if the tendency ratio is what? N is to 1, right? This is first observation. Okay, now we can get the input impedance. Input impedance. What is the circuit? Right, this is the circuit. From this what we are having? Plus minus, so this is Z input, right? This is Z input, this is I1, I2, and this is what can have supply voltage is V and K is equals to 1 and current ratio is what? N is to 1, and we have what? Dot convention. This is L1, this is L2. Across secondary we have a load, across load we have the voltage, that's it. Okay, we know that, or we can write this also, V1 by V2 which is equals to N1 by L2 which is equals to I2 by I1 which is equals to N by 1. It is totally depends upon the mutual inductance only, okay. You can write minus I2 by I1 or I2 by I1. Okay, it's totally depends upon the current direction. Okay, if minus I2 by I1 is there, that is minus M. If I2 by I1 is there, that is plus M. There is no doubt in that. This is for minus M, this is for plus M. Okay, we know that from this V1 by V2 which is equals to N1 by N2 which is equals to I2 by I1 which is equals to N, right? From this can we write V1 by V2 into I2 by I1 which is equals to what? N1 by N2 into N1 by N2, right? Can we write like this, which is equals to N1 by N2 whole square. N1 by N2 is nothing but what? N only. Therefore, we can write V1 by I1 by, this is what? V2 by I2 which is equals to N1 by N2 whole square which is equals to what? N square. V1 by I1 is nothing but what? Z. This is what? Z. This is what? Across secondary, right? That is Z2 or secondary. Secondary, right? Therefore, we can write input impedance is equals to N square into secondary impedance. That's it. Finally, we have the relation between N square into Z secondary, provided transfer ratio is what? N is to 1. Okay. Next, two-port network representation. Next, we have to discuss two-port network representation. You all know that transformer is a two-port network device, right? V1 by V2 which is equals to N1 by N2 which is equals to, here I am providing minus I2 by I1 which is equals to N, right? So from this we can write V1 which is equals to NV2 and I2 which is equals to what? Minus N I1, right? First we have to represent H parameter representation. In case of H parameter representation, what we have? V1 input supply voltage 0 into I1, we don't have any parameter, but NV2 coming to I2, right? Minus N I1 but 0 V2, right? So from this we can write V1 I2 which is equals to 0 N minus N 0 I1 V2, or we can write V1 I2 which is equals to 0 N 0 minus I1 V2. We can write in this manner, right? Therefore, next we have to write ABCD parameter representation. T parameter representation. In this, what we have? P1 which is equals to NV2 minus 0 I2, and what about I1 which is equals to 0 V2 minus 1 by N I2. Therefore, what we have? P1 I1 which is equals to N. Here we have what? N 0 0 minus 1 by N. You can write V2 I2, or you can write N 0 0, or you can write P1 I1 which is equals to N 0 0 1 by N. Here V2, this is minus I2, no problem at all. Now we have to check condition for reciprocity. Condition for reciprocity. So in case of H parameter representation, what is the condition? H12 is equals to minus H21, right? So from this, N which is equals to minus N, so N which is equals to N, satisfied. Like that, P parameter representation. What is the condition? Mod AD minus BC which is equals to 1, which is equals to what? AD is what? N into 1 by N minus 0. That is N into 1 by N minus 0 which is equals to 1, right? So 1 which is equals to 1, satisfied. But this is not symmetrical. Therefore ideal transformer is reciprocal circuit but not symmetrical, right? This is very, very important. And one more important point, no representation for Z and Y parameters. Only we have what? H and ABCD. Clear? Okay. Reciprocal but not symmetrical. Now we have summary. Very, very important summary. First point is what we have? V1 by V2 which is equals to N1 by N2 which is equals to minus I2 by I1 which is equals to N by 1, right? Considering turns ratio is what? N is to 1. Okay. Second observation is what? Input impedance which is equals to what? N square into impedance of secondary. Third observation is what? H parameter is what we have? 0, 1 by n, sorry, n only. N minus n, 0. And what about t parameters, which is equals to t is what? n 0, 0, 1 by n. N 0, 0, 1 by n. That's all. Okay, this is the analysis. For example, if turns ratio is 1:n, if turns ratio is 1:n, then that is n1 by n2 is equals to 1 by n. That is the mean. Then first observation, v1 by v2 which is equals to n1 by n2 which is equals to minus i2 by i1 which is equals to, now it is 1 by n. Okay, second point, input impedance which is equals to z input which is equals to, now it is 1 by n square impedance of secondary, right? 1 by n square impedance of secondary. Next, third observation, H parameters. H matrix is nothing but what? Here we have what? 0, n minus n 0. Here we are having 0, 1 by n minus 1 by n 0. And coming to t parameters, that is ABCD parameters, we are having 1 by n 0, 0, 1 by n. Sorry, here it is 1 by n, right? Sorry, it is n. That's it. Turns ratio is very important. So based upon turns ratio only we can do the analysis. This is about ideal transformer. In this, what we have, that is relation between turns ratio and input voltage, output voltage, and input current and output current, right? See, relation based upon turns ratio, if it is n:1, we have this relation. If 1:n, we have this relation. If n:1, input impedance equals to what? N square into secondary impedance. If it is 1:n, 1 by n square into secondary impedance. Like that we have H and T parameters. Here also H and T parameter. This is about ideal transformer.